So with that in mind, let's head over to our client script. So here we are in our client script, and let's go to our player's update method. So we want to work on maybe moving the player around the board. So here is our player, and here is the player's update method. So what we'll do is we'll check to see if a particular key is being pressed right now or being held down. And if you recall, to check whether or not a key is being pressed is not an event. It is very different than trying to execute something on the actual pressing or releasing of a key. Those are Pygame events. But just saying like, hey, what keys are currently being pressed, you can get a list of all of those keys. And so let's actually get a list of all of those keys. So we'll see, check to see what keys are being pressed. So to do that, we'll simply call this list keys, and we call pygame.key.get pressed. And so this is going to return us a list, and inside of that list you're going to have a bunch of keys, and those keys, is it a list or a dictionary? It might actually be a dictionary. No, I think it's a list. Regardless, I'm not sure. It could be a list or a dictionary. But what will happen is you will, for each item in, whether it's a list or a dictionary, you'll have a key name and then a value like 0 or 1. 1 is if it's being pressed. 0 is if it's not being pressed. So now that we have that list, we're going to just quickly make a rect for our player that is going to just help us kind of chart their movement. In particular, it's going to help us put movement restrictions on the player so it can't go off our screen. So we'll say create a rect to chart player movement. So we'll do player underscore rect is equal to pygame.draw.rect. We're not actually going to draw it at all. We're just creating it so we can put some boundaries here. We'll say display surface is the surface in question where we want this rect to be. The color would be our player's primary color, or our self.p color. And the position will be the player's coordinate, self.coord. Remember, coord is a starting x and starting y, and then a width and a height. And we have all of that in the player's coordinate. All right, so now we'll say only move the player if the player is playing the game, right? Because if you think about it, the player's update method gets called every iteration of the game loop. We don't want the player to be able to hit arrow keys and move the player when we're like waiting for other players to join or we're waiting for everybody to get ready. We only want to be able to move the player if the player is playing. So we're going to say if self.is playing. If that Boolean flag is true, now what are we going to do? Well, what we'll do is we'll check to see if a key is being pressed to move, and if it is, we'll change the player's dx or dy attributes to signal that we are going to change their coordinates in that given direction, either the x or y direction. And so what we'll do is we'll have a bunch of states here. I'll actually probably have 5 cases, one for moving up, one for moving down, one for left, one for right, and then the 5th one will be no movement at all. So maybe, no keys are being pressed, so we should stop moving. So let's see how we are going to do this. All right, so I'm just going to adjust something here on my second monitor really quick. All right, perfect. So if the player is playing, we'll first check the upstate. So we'll say if keys, that list, and if the element pygame dot k underscore up. So that's the up key. So if the player is pressing the up key and, right, so the player might press the up key, but we don't want them to move past the top of the screen. So we got to put some restrictions here. So we're going to use that rect that we created to help us with those restrictions. So, and the player's rect dot top is greater than 0. Remember, for the y direction, we start at 0 on the top, and then as we go down, it gets bigger. So if it's like 15, well, that's greater than 0. We got room to move up. But if it's at 0, then we shouldn't move up anymore. We should stop. So what are we going to do? While moving up, we're going to say self.dx. We want no movement in the x direction. And self.dy, we do want movement in the y direction. We want to move up, so we're going to subtract the y value. So to do this, I'm going to do -1. That will indicate subtraction. direction. And then how much do we want to subtract? Well, we have specifically designed the game such that the rooms are divisible by the player size. So, if the room is 600 and the player size is 60, well, then that's divisible. When you do that division, you get 10. So if I'm at the bottom of my game window, I should be able to move up 10 times until I get to the top. So we're going to move by player size increments. And so that's stored in our self.size. Remember, over here on the client right now, we're in the player class. So we'll reference the player just by using the self attribute or the self keyword. All right, perfect. So now let's do an elif. So elif keys square brackets pygame.k underscore down. And now we want to make sure if we're moving down, we're moving down, we're moving down. We don't want to move past the screen. So the bottom of our rect has to be less than our window height. So we'll say player underscore rect.bottom is less than window height. All right, our constant variable window height that we got from the server. We'll say self.dx is equal to 0. We're not changing in the x direction. And self.dy is 1 times self.size. I could just write self.size. I like to put the positive 1 here just to kind of give me an indication that we're moving, up and down. Okay, wonderful. Now let's do the horizontal direction. So elif keys, what would it be? Pygame.k underscore left. We'll do left. And player rect.left. So now we should be able to move to the left until the left side of our rect. Remember, 0 is over here, so we want it to be greater than 0. Once it gets to 0, we can't move to the left anymore. Greater than 0. And so we'll say, now we're going to update the dx value. So self.dx is -1 times self.size. And we're not moving in the dy direction anymore, so we'll set dy to 0. And then we'll do the right, elif keys pygame.k underscore right. And we'll look at the rect, player rect.right. So if you think here, this has got to be less than our window width. And otherwise, we'll be at the edge of the screen and we shouldn't be able to move right anymore. So if that's the case, right, we're good to move. We'll say self.dx. And dx, dy, right, these are just like, I don't know, they're like calculus terms for change in x, change in y. So the change in x here is going to be 1 times the self size. So self.size. And the change in y will be 0. We're not changing in the vertical direction. And then lastly, what do we do if none of those keys are being pressed? Well, then we're just going to stop moving. So we'll say self.dx is 0 and self.dy is 0 as well. All right, so that's going to cover a lot of this method right here. I think that that's going to work really nicely. So now that we've processed the movement of our player, let's actually update our player's x and y attributes based on whatever the value of dx and dy are. So it'll move it in the direction we want to move into. So we'll say update the player's current coordinates. So we'll say self.x is plus equals self.dx. So if dx is, we wanted to move to the left, if it's a negative self size, so I don't know, like -20, we'll take their current x and subtract 20 from it. So that looks great. And we'll do something similar, self.y plus equals self.dy. And then let's update our coordinate. So self.coord, which we're using for drawing and comparisons quite often here, we'll say self.x, self.y, so our starting point in the x and y direction. How wide do we want our rect to be? It's self.size. How tall do we want it to be? Self.size. Awesome, awesome, awesome. So our player's update method, I believe, is complete. Now, the player will update since we're calling this method inside of our main game loop. So let's go down and look at that main game loop here really quick. So I'm going to scroll down. Here is my main game loop, and I'm calling my player.update right here. Now, there's nothing wrong with doing this here, and you don't have to do what I'm about to do. But I prefer to really only update and draw my game object. So I'm going to actually remove this right here. I'm not going to update the player directly. What we'll do inside of the game's update method, so you can see I have a mygame.update, I'll just call the player update from inside of the game. I just think it makes my game loop look a little bit cleaner, and I tend to like that. So now let's go to the game's update method. So let's scroll up. We're calling the game's update method, so let's actually work on writing this. So, similar to the player, we only want the game to update if the player's is playing flag is set to true. So, we'll say only update the game if the player is playing. So we'll say if. Now we're inside of the game object. So how do we access the player's is playing flag? We access the player first, self.player, and we'll say dot is playing. So if that is the case, we'll update the player first. And by calling my we can't, we could call my, I guess we could call my player from inside of here, but instead we'll do self.player. I just copied and pasted that over. Inside of here, the player, inside of the game object, the player is referenced as player. Outside of the game object, it was referenced as my player. But let's keep it as self.player.update. And now we'll update the game. So what do we have to do to update the game? Well, at this point, we don't really have to do much. I mean, we don't have to like keep track of a clock on our end here and every, iteration of the game loop try to figure out how many frames have gone by, because we're not keeping track of time on our individual client. Rather, that's going to happen on the server for us, and we'll just simply get the time from the server. However, one of the things that we should do in our update method, and this is going to be important, every iteration of the game loop, we should check to see if the game has ended. Essentially, we should check to see if our round time attribute is at 0. So recall our game object has a round time attribute. Right? And so it starts as the round time that we got from the server, and then our goal is that we're going to decrement that by 1, every second. When it hits 0, well, that means the game's over. So we should do that in our update method. We should check for that. So we'll say if self.round_time equals 0, what do we need to do? Okay, so first, if the round time is at 0, means the game is over, or the round is over. So we should say self.player.isPlaying is equal to false. They're no longer playing, and they're not ready to play yet. So we'll say self.player.isReady is false as well, and just to ensure that. But what are they doing? They're waiting to play the next round. So we'll say self.player.isWaiting is equal to true. So you imagine when the timer hits 0, it's going to say something like game over, press enter to play again. When they press enter, what we'll do is we'll change is waiting to false, and we'll set is ready to true, and we'll monitor to make sure every single player is ready. And when every single player is ready, we'll set is false back, or is ready back to false, and we'll set is playing back to true. And again, we'll pump this all to the server. The server will collect it and send it back to us. Why don't we actually change our status message here? We'll say self.player.status message is equal to what do we want to say here? We'll just say game. We'll just say game over. I think for right now. Actually, let's say game over, and then we'll say enter to play again. So we'll actually prompt them to play again. Okay, so I think if we run this at this point, we should be able to sort of move our clients around and check everything out. So let's see if this is working. So server's listening. We'll run our client, and let's see if our player's update is being called correctly, and we can actually move around the screen. So we'll run. Okay, so we got our 2 windows open for a 2-player maximum. I'll hit enter over here. I'll hit enter, and we've got an error. Of course we got an error. I've been making a lot of mistakes, so I apologize for this. Where is the error? Okay, so it's in my client file. On line 89, it says list object is not callable. So line 89, so in my client file, line 89, right here. Oh, I made this mistake earlier in a video. I'm not trying to call self.coordinate. I want to assign self.coordinate a new value. I forgot the equal sign, which is a really just silly mistake. But we make mistakes, don't we? So I'll fix that right there. Again, some good debugging in real time. So let's run this again, and hopefully it's not the third time is the charm. Hopefully the second time is the charm right here. So let's see. We'll run it. We'll test it. And let's see if we can actually move our players. All right, press enter to play. Here's the other one. Press enter to play. I press enter, waiting, play. And so here I am moving my player quite nicely, and here I am moving my player quite nicely. So this is working pretty good. You may see a little bit of a lag. I think the lag is because my frames per second is pretty low. Let me up my frames per second on the server. Yeah, right now I'm capping the frames per second at 15. Let me put it at like 30 or something, and I think that will be a lot better. So let's just see. I'll run this. Server's running. Client's running. Our next client is going to run. And now, essentially, we're telling Pygame, hey, the fastest you can run this now is 30 frames per second, which should be a lot smoother. So we'll hit enter, and now that's a lot better, I think. I'm a lot more happy with that. And over here, this looks pretty good too. Awesome. If you go to your client script in the draw method of the game, so scroll down, there's our game object, we're in our game object. Here's our draw method. So we're looping through each player's current state in the game state list. So remember, we sent our state to the game compiled, or the server compiled the game state for all players and sent it back to us. And so we're drawing our player based off of that game state, which I think is probably the state for the previous iteration of the game loop. For the current iteration of our game loop, the player's coordinate has advanced 1 bit, which is why our rect is always 1 in front. So what we can do to fix this is, before we draw our outline, let's just redraw our rectangles for this player. So we'll say pygame.draw.rect. We'll do a display. Surface is where we want to draw it. The color is going to be our player. So we're going to reference our player as self.player.primary color, or .p color, and our coordinate will be this player's coordinate, self.player.coordinate. Now what will happen is we'll draw our player's coordinate from the previous frame, and we'll draw their current coordinate for this current iteration of the game loop. And I think it's going to look a little bit better. At least now that box should hopefully be filled in. So let's take a look. So we'll run this and test this out. Yes, we're ready to run. We're ready to run it. So here is our first object. Great. Here is our second object. Great. Doop doop. All right. So we got the two clients running. We'll hit enter to test it. Hit enter. And so now I think that looks a lot better, right? We got a little bit of like motion blur, which actually I think is kind of cool, right? We could actually put in a test to make sure we're not drawing, this players, but I like how it kind of expands as you're moving around the screen, and then you stop. So I think that looks a lot better. So I'm happy with that change. All right, so with that visual change out of the way, let's actually discuss what the heart of this video is essentially going to be about. So right now, our client can actually run the game on their end, for the most part, right? We now have to work on making sure that the server is receiving updated client information. Then they're going to create an updated game state for all players and compute the time, the score, the winning player, and then send all of that information back to each individual client. So this is a bit of an undertaking. The first thing that we have to do is ensure that the client is actually sending their current information, like their coordinates and their flags, each and every iteration of the main game loop. Now, recall, we are calling the game's update method each iteration of this game loop. So what we'll do is, inside on our client, we're going to go to our game class. In the game's update method, which is called every iteration of the game loop, we'll make a call to send our specific player's information over to the server. So right here, at the end here, if the player is currently playing, we will say send the player's current info to the server. So we'll say self.send player info. All right, so we're making a call to we're making a call to send player info, and if you look, send player info is already written. This is awesome. We already wrote this because we've already used this method, right? So we're going to send our updated coordinate and all of our status flags over to the server. Awesome. So, and that's going to happen every single iteration of our main game loop. We're going to try to send some information over to the server about our current position and our current status flags. So now let's head over to the server to make sure that we receive this information. So if we think, the server has to essentially continuously be listening for these incoming packets from each and every single client when the game is being played. So we definitely need some threads for this. The question is, where should we start this thread? Well, we should start the thread once the game has begun. And if you recall, we are signaling the start of our game, I think, in our ready game method. So if I go on my server now, we're going to go to the game object. And we're going to go inside of the game object to the ready game method, which is right here. Whoa, I highlighted all of the text on the screen, and I said right here. So inside of here, if we look, we are starting the game right here, and we're sending our updated player flags to say, hey, time to start the game. So now that we have started the game, what we'll do, we'll say now that this player has started the game, and remember, the ready game method is running in a thread for each player that is connected to the server. So now that this player has started, create a thread to receive game information. And so we'll call this receive thread, and we'll make, say, threading.thread, and what will our target be here? Our target, well, what do we want to receive? We want to receive player information. And if I just scroll down, I'm going to highlight this so I know where I'm at. We've got receive pre-game player information. That's already written for us. That's kind of nice, but we're not pre-game anymore. We're actually playing the game. So we should call our target receive game player information. We're targeting, this method because now the game is actually being played. And we have some arguments. We got to make sure that we pass in the player and the player socket, which is not a problem. I know we have access to both of them, player and player socket. So we'll just forward them along here. So we'll say, okay, in this thread, we are going to target target is equal to self.receive game player info, and our arguments, args, are an iterable, so we'll make them a tuple, and we're going to send in our player and our player socket. Socket, not a soccer. That would be funny. And now we're going to start this thread. So let's start this thread. So receive thread dot start. Okay, so we've started the thread, so now we should probably go write receive game player info. Let's go write this method for our game class. So if we just scroll down, here we are, receive game player info. Okay, make sure you're in the right one. Don't put this in pre-game player info. We are in game player info. What do we want to do here? Well, we want this thread to run continuously as long as the current game round is being played, such that the server will always be listening for updated player coordinates during the game round, right? Every iteration of the game loop, the player is going to change their coordinate, and we want to get that information every iteration of the game loop. So we'll use a while loop. So we'll say while, but we don't want to do it forever. We only want to do it while the player is playing. Which player? This player right here, which is the player that the thread is running on. So we'll say while player dot is playing. All right. What do we need to do? Well, we've got to get some information from the player. So let's go back to the client and let's check what they are sending over. So I'm just going to highlight that so we know where we are when we come back here. If we look, we are sending player info, and send player info, we are sending a coordinate and a bunch of status flags. Cool. All right, so let's grab that stuff. So while player is playing, we'll first get a packet size for our header. So we'll say, I just got to make sure I'm at my right indentation. Okay, packet size is equal to player socket. So here is our socket. We have access to it. Player socket dot receive. And the packet size is going to be our header length, which is stored in our connection object. So self.connection.header length. And then we have to decode this. So self.decode, and we'll do self.connection.encoder. Perfect. Now that we have that packet size, we'll use it to get our player information that's coming in. So we'll say player info JSON is equal to player socket dot receive. And now that message packet is going to be packet size. So we're only getting the information we want out of the data stream. And here we will turn it back into a dictionary. Remember, we've said this is like an encoded string. So we're going to say player info is equal to, we'll use JSON.loads to decode it and turn it back into a dictionary for us. Player info JSON. All right, so now that we've got some new player information here, we should set the updated values for the given player. So we're going to say set the updated values for the given player. All right, so we'll say player.set player info. The player has a set player info method, and we'll pass in our dictionary player info. Now let's go look at this, because I think here it might get a little confusing. I'm just realizing. So we're calling the player's set player info method over here on the server, and we're passing in our player info dictionary, which we just got from the client, which has a coordinate right here. But if we look on the server side, in our player object, so here's our player, in set player info, oh, we are setting a coordinate. Never mind. This is going to work out great. I don't know why I got confused. Oh, I got confused because on the client side, set player info, we're not setting a coordinate. So this is okay. I apologize for that. I didn't mean to confuse anybody if I did. So here we are in receive game player info again. We've just set the player's information that we have received. Okay, so this looks pretty good. So now in our receive game player info method, what do we want to do if the status flag is playing is false? Well, what we'll do is we'll back out of the while loop and we'll say if that flag is false, then the game has finished. And we should monitor for the restart of the game. All right, so in order to monitor for the restart of the game, we need a thread, right? We essentially, when the game ends, if we look over here on the client side, when the game ends, which I think we're checking in the game's update method, update the game. If the game ends, we're saying game over, enter to play again. So we're prompting the user to eventually press enter, and I'm sure that that's going to change their is ready flag to true. So we want to monitor that status. They're going to send that over to us once it's changed, so we're going to call a ready thread to listen for that incoming message. Threading.thread. And inside of here, we are going to target a method that is going to help us ready the game. And I believe, look at that. We've got one. It's the ready game method. And we've already written this because we had to ready the game when the players first loaded in, when the clients first loaded in. Well, we got to do the exact same thing here now for a game kind of like reset. So we'll say self.readyGame, and the args, we need some arguments here. It's going to be a tuple. We'll pass in our player and our player socket. Great. And then we'll start this thread, ready thread.start. And what this will do is it should essentially repeat the process. So when the game's over, the server will start listening again for another incoming packet. And when that packet comes in, we'll check to see if the ready flag is set, and if it is, we'll start listening for all players is ready flags, and once that happens, we'll change each individual's is playing flag to true, and then send that back to the server so the game can essentially restart. Awesome. So this is really good. So now let's talk about what we do once we've actually updated the player, right? So the player has changed its coordinates. We've changed some information. And there's going to be some pretty big implications to the overall game state. And you can see here we've got a method called process game state. I think we want to call process game state after we've updated the player's values. So right here, we're going to go back inside of our while loop while the game is playing, and we're going to say process the new game state to see if a player scored points, or something like that. So we'll say self.process underscore game state, and we'll pass in, it needs a player and it needs a player socket. We've got access to both within our thread that we're running for this individual player. So player and player socket. All right, great. So let's go look at process game state now. So inside process game state, the first thing that we're going to do is we'll update our round time. So if you remember, we had a variable, and I'll just highlight myself so I know where we are. I don't get lost because we're getting pretty big in scope here, and this is a tough process to keep track of. If you remember, we have a start time. When the game started in the ready game, we said self.start time. We called the time module's time method. So it got like a snapshot of the time in the server clock. So let's get the current time now. So some time has elapsed since we started that time. So we'll say self.current time is time.time. So we'll call the time module's time method. And now, using those two times, let's figure out what the actual round time is of our game. So we'll say self.round time is equal to, and if we think about it, we had a starting time, round time, minus, so if that was like 30, I'm going to subtract how many seconds have elapsed. So inside of here, these are floats if you looked at that documentation. So we're going to turn these into integers. Self.current time minus self.start time. All right, and these are going to be, so we've got integers. I think that might be all I have to do. Round time minus, well, we'll see. We might have to come back to this to fix it, but I think that's pretty good. So if this is like 30 seconds, round time is 30, and current time is, I don't know, 1,000,000, and this is, or if 1,000,001, and this is 1,000,000 seconds, we'd get 1 second. 30 minus 1 is 29. So that means round time would be 29 seconds. I think this should work. And if it doesn't, we'll just come back and fix it. Okay, what's the next thing we want to do in our process game state method? Well, we're going to look to see if this particular player was able to collide with any other players. So remember, we said that if you collide with a player, you will earn a point and you will get repositioned back to like your home base. And so those are some of the things that we want to do. So what we can do here, we'll say process collisions for this player. We'll say for player object in our player object list for the game, self.player object. So we're going to loop through each and every player object, and then we don't want to, so we'll say don't collide with yourself. All right, self, that would be bad. So we'll say if player, our player that we have right here that this thread is running on, is not equal to player object. Now what we can do is let's look to see if their coordinates are equal. So if player.coord, the player that this thread is running on, is equal to player object.coord, the player that we just looped through, well, then that means that this guy has collided with this guy, and we should give a point. So we'll say player dot score plus equals 1. So we're going to update this player's score. And remember, that score is only local on the server. I'm not pushing that score over to the client yet. No need to. And then we'll update the player's x position. So player.x is equal to player.startingx, their starting x position. Player.y is equal to player.startingy. We'll update their y position back to their starting y. And then we'll update their coordinate. Player.coord is equal to player.x, their player.y. So they'll go back to that starting position. And then how big should the rectangle be? Player.size in the width and player.size in the height. All right, I think that looks pretty good. So what we should now call is, if you think, we've just processed this game state, we've updated the time, that looks pretty good here. We've processed for collisions, I think that looks pretty good here. So right now, what we'll just end it here. We'll say we're going to send the updated game state back to this player. And what we'll just simply put in here is self.sendGameState, and we've got our sendGameState method right here. All we need to do is send it to a specific socket. So we'll send it to the player socket that we've kind of been passing along in these methods. So we'll say player socket. Okay, I think this is pretty good. This is a good place to stop. In our next video, we'll start by writing our sendGameState method, and we'll begin to see whether or not this information is getting passed to all of our clients in the way that we want that to happen. So if you scroll down a bit, you can see that we are calling process game state. And we've already written process game state, but we've ended processing that game state by calling send game state, which we currently have to write. So let's start working on sending this game state back to our player. So we'll get rid of pass here. The first thing that we'll do is we'll initialize a blank list called game state. Game state is a blank list. Perfect. And this is going to hold all of our players' information. So now what we'll do is we'll loop through each connected player's player object. So and we're going to turn their player object into a dictionary. So we'll say turn each connected player object into a dict, then a string, then encode. Well, we'll just say dict and then string, because we're not going to encode yet. So what we'll do is we'll say for player object in self.player objects. Remember, we got that list in our game object of all of the connected player objects. Let's turn the player object into a string. So we'll say player JSON is equal to JSON.dumps. So what do we want to turn into a string? We want to turn the player object. But this is a Python class, and we can't really do that directly. But what we can do is call __dict _ on this class. So here's the class that, a particular player. We're going to get a dictionary version of it so that all of the class's attributes are key value pairs. Now we have a dictionary, and we've turned it into a string, which we can later then encode. So let's take this string and append it to our game state now. So we'll say game state.append player JSON. All right, so that looks pretty good. So now game state, if we've got 4 players, game state is going to have 4 elements in it. Each of those elements is going to be a string representation of a dictionary representation of our player object. So that's, there's a lot there. But now that we have it, let's send it back to this particular player. So we'll say send the whole game state back to this player. And so remember, we're running these in threads, so everybody's going to get this. All of our players are going to be this player in their respective threads, if that makes sense. So we'll say, okay, this is a list, and we can't encode a list, so we got to turn this into a string representation of the list. So we'll say game state JSON is equal to JSON.dumps game state. All right, so now that list has become a string, which we can encode. Let's get the length of this list as our header. So we'll say the length of game state JSON. But we know that this is an integer, and we're going to want to add some white space to it. So we're going to turn this into a string. And now that it's a string, we can use the length function on it. So we can say, well, the length of our header is less than our header length, which is stored in our connection object. So self.connection.header length. What do we want to do? Well, we've seen it before. We're going to just add a white space character until the header is the exact size we declare it to be. Now that it's that exact size, we'll send the header over, which has information about how big the next incoming packet is going to be. So we'll access our player socket, which is right here. All right, so player socket.send. What are we sending? We're sending our header, but that needs to be encoded. So we'll say .encode, and our encoder is found in our connection object. So self.connection.encoder. All right, now that header is over, let's send the game state JSON. So we'll say player socket.send. Why can't we just send the game state? Well, we can't encode a list, so we turned it into a JSON so we can encode it. So we'll say game state json.encode, and we'll pass in self.connection. Oh, I got to spell connection right. I know I've made that mistake a few times. Self.connection.encoder. All right, wonderful. So this is pretty good. So now that's going to send our compiled game state, but we've also in the process game state, we've updated our time. So let's send our time over too. So now we'll say, hey, in here, let's also send the server time. So let's get a header. So we'll do header is equal to, so if we let's think about this, self.round time. I believe round time is an integer, so we're going to cast it to a string. All right, and now we want to get the length of this string, so we'll call the length function on this. And now the length is going to be an integer, and we want that to be a string. So I'm going to cast that to a string. I think we have to do that. Maybe we don't. I know this works. I think that is the thought process, right? If this is an integer, in order to call length, we've got to cast it to a string. When we call length, we get an integer, but we want it to be a string. Okay, so now that it's a string, we'll say, well, length of our header is less than self.connection.header_length. We will add a white space character plus equals to the end of our header, and now we'll send through our player socket. So player socket.send, we'll set our header dot encoder self.connection.encoder, and then we'll send our current round time. So we'll do player_socket.send the string representation of self.roundTime, because I'm pretty sure round time's an integer, and we want to encode this. We got to make it a string. So it's a string now, so we can encode the string with our self.connection.encoder. Okay, so we'll send that time over. That way, each client knows how much time is left on the round, and we've already updated that time in our process game state right here. Okay, so I think this looks pretty good. I'm going to save my server, so Control S to save the server. And so now what we have to do is we have to go back to the client. And you notice that's kind of how we've been operating, right? We work on one side, we figure out what we want to send, and then we go to the other side and we figure out how are we going to receive this. So we have to receive the game state and the time and then update our client side based on that incoming information. So if we head to the client script and we look at our game objects update method, so it's right here, the game objects update method, you can recall that the update method is called every iteration of our main game loop. And you can see here that we are always sending our player information over to the server, each iteration of that game loop. So as we move our player, we're sending that information over to the server. And what the server is now doing is it is gathering all connected players, information and putting it into our game state, and it's trying to send it back to us. So we definitely want to make sure that every iteration of this game loop, we are also receiving that information. So, in our code right here, or in our comment where we just say send the player's current info to the server, I'm actually going to change that. And I'm going to say, and receive an updated game state. So we want to make sure that we're also receiving something every iteration of our game loop. And so we'll call self dot. If we scroll down just a little bit, or actually I think we got to scroll up, we've got receive game state, receive all information about all players from the server during the game. So we definitely want to call this method and then write this method. So we'll say self dot receive, RECIEVE, game state. It's easier for me to spell correctly if I actually say it out like that. So I think this looks perfect here. Okay, so let's go write this method right now. So I'm just going to scroll back up. Here we are in receive game state. So what do we need to receive? Well, recall, what are we sending over? We're sending over the game state, and then we're sending over the server time. So we got to grab both of those things in this method. So we'll say receive the game state. So we'll get the packet size of the incoming message. Self. Now we got to get to let's just remember, we got to get to our socket, which is stored in our connection object here inside of the game. So self.connection.player socket. Yep, .player socket. .receive. How big is the header? Well, it's self.connection.header length. length, and then that's a bytes object, so we're going to decode, and we're going to put in self.connection.encoder, and that's where we're storing our UTF encoder. Okay, and so now let's use the packet size to get the game state. So we'll say game state JSON. It's going to be a JSON file when we get it. Is self.connection.player_socket.receive. How big is this packet? Well, we got that information from our packet size. So the header told us. So we'll say we want the int value of packet size, and we've done this before, which is why I'm moving a little quick here. We don't have to decode it. JSON will do it. So we'll say, hey, game state is equal to JSON.loads, and we'll pass in game state JSON. So remember, this is an encoded string. We pass it in. It's no longer encoded, and this is a list now. So that's going to be a list. And so now we have a new game state. If you recall, our game object on the client side, if I scroll up to where we initialize it, it has a game state attribute, which we initialized as a blank list. So let's update the game object's game state attribute here on the client end. So, right, we've got a new game state. So let's update our, we'll say update the client's game state. So we'll say self.gameState is equal to game state. All right, that worked pretty good. So that's going to get us our game state. Now let's get the server time. So we'll say receive the server time. So again, we'll do a packet size. So packet size is equal to self.connection.player.socket.receive, self.connection.header length, and then we'll decode it, .decode self.connection.encoder. Now that we have that, we can receive the round time, and we will set the clocks. I think we have a round time attribute, don't we, in the game object? Let's just scroll up and make sure we have a round time attribute. Yep, variables to hold the state of the current gameplay locally. We have a round time attribute, and so it starts at the maximum value, and then we're decrementing it over on the server. So let's update that value. So we'll scroll down. Where were we? Receive the server time right here. So we'll say self.roundTime is equal to self.connection.player.socket.receive, and in here is going to be the integer value of our packet size. And if we think, we should probably decode it, right? We got to decode this because this is going to be a string, and so we'll decode it. .decode, and we'll pass self.connection.encoder here. All right, perfect. And I think, yeah, I think this works out pretty good here. I think this works out pretty good. We could cast it to an integer. We could cast round time to an integer right here, but maybe we'll do it. We'll do it later. We'll do it later, I think. Okay, so this looks great here. So now our client has access to the updated game state and the updated time, and our game state is going to include things like every player's score, everyone's current position. So let's process the game state to see what updates it might have on our current game loop. And so over here on the client side, we have a process game state method. So we'll say process the game state information. So we'll call self.process game state. Okay, so let's go right process game state. All right, in process game state, we're gonna do a few things. First, I'll say we're gonna do them all based on the data that was passed over from the server, right? So first, we'll update our player, the player that is connected to this client's coordinates. So we'll say update the players. We'll say update this player's coordinates in response to a collision. So if you remember, on the server end, we said that where we are in process game state, if our player collided with any other player, we gave them a point, and then we change their coordinates. We position them back at their home base, at their starting location. So what we want to do is make sure, oh, where'd my IDE go? Here we go. What we want to do is we want to make sure that if that collision occurred, we update the coordinates here on the client side. So we're going to say for player in self.gameState. So if you recall, gameState, we've attached it right here to our game, is a list, so we can loop through that list. We have a player in each list. What we have to do, though, that player is currently a string, so we're going to say player is equal to json.loads player. So we'll turn it back into a dictionary, and so now I'll say player is now a dictionary. We're going to check first to see if player, if their number is equal to our own player's number, so self.player.number. So is the player in the iteration of this loop, is their number equal to the player that this client is running? So if they are equal, then we will update their coordinate. So we'll say, okay, self.player.cord. Our coordinate is going to equal the player dictionary, and we'll access the cord key. And then let's also update our x and y values. So we'll say self.player.x is equal to, we can do self.player.cord. We can do the first element in the coordinate, and then we'll do self.player.y is equal to self.player.cord. We can do the second element in that coordinate. You probably could have also just grabbed them from the player in the dictionary. You could have done player X and player Y, but this works out too. Okay, perfect. So that's going to update our coordinates. So that should make sure that when a player collides, they are effectively moved back to their home base. So they're moving around the screen, they collide, they get a point, and then they go back to their home base. You can think about it as maybe like they deposit the point by going back to their home base. So now what we'll do, let's see, what do we want to do next? Well, while we're looping through each player, let's also get whose score is currently the highest. So if you remember, we're not keeping track of a client score locally on the machine, although that information is over on the server. But let's try to figure out like who's currently winning the game here for us. So what we'll do is I'm going to start at the top outside of the for loop. I'm just going to create a list. I'll call it current scores. And it'll be a blank list. And now in here, what we'll say, we're looping through our players, we're turning the players back into dictionaries. What we'll say is determine who is currently winning. Now, if you remember, I'm going to just scroll up to our game's initialization method. I think we have some, here's our game's initialization method. We've got some variables that are going to help us here. We've got high score is equal to 0 and winning player is 0. So that's going to help us out a lot. I think we're going to update these values, our high score and winning player attributes, now. So here we are back in process game state. So we're looping through our player dictionary. So player, our game state list to get our player dictionary. So player is a dictionary, and we're going to say if this player is score is greater than self.high score. So if it's greater than high score, then what do we want to do? Well, we're going to change our winning player. We're going to say self.winning underscore player is no longer 0. It will be assigned to the player that we're looping through, its number, so player number. And we will set our high score. So we'll say self.high score. Ooh, don't capitalize that S. Self.high score is equal to this player's high, well, it's not high score, it's just score. All right, so that'll loop through and update who is currently winning and what the current high score is. But we also could have a condition where we have a tie, and so we want to make sure we do some stuff for that. So we'll say inside of our for loop, as we're looping through each individual player, we're going to add the score to our current score list to process for a tie, we'll just say. So I'm going to say current scores.append player score. So this is just a local variable that will exist inside of our function, but it's going to help us. Once this for loop is done, and we've run this for loop for each and every player, we'll know who the winning player is, what the high score is, unless there's a tie. Because if there's a tie, We're just going to give it to the first person that it happens to be in the for loop, which is why we're creating a list of all of our current scores here as we're looping through them. So now that we have that list, we can check for a tie outside of the for loop. And so how are we going to do this? Well, I'm going to just create a counter variable. I'll call it count is equal to 0, and we'll say for score in current scores. So I'll loop through my list of current scores, which we've appended to right here. What I'll do is I'll see, is the score that we're looping through equal to self.highscore? Is it equal to the high score? If it is, I'm going to increment count by 1. And you know what? I don't like the name count. We'll say count's fine. So as long as that variable is equal to 1, we're good. That means there's a clear-cut winner. But what we'll say outside of the for loop, if count is greater than 1, if it is 2, if it is 3, if it is 4, then that means there is a tie. So I'll actually put a comment here. I'll say there is a tie for first place. That means no one is winning. So if no one's winning, what should we self.winning player to? Well, we'll set it to 0. 0 will be the value that we use for a tie. Okay, and so that looks great. All right, so now what we can do is let's head to our update method. Actually, no, I think our update method is pretty good. Let's head to our draw method. Our draw method is what we want to do now because we've got a lot more information that we want to draw, I think, to the screen. We've got scores, we've got times, all that good stuff. The first thing that we'll change here is we're going to give some visual feedback for who is winning the game. So the first thing that I'll do at the top of my draw method of my game, I will say we're going to fill the display to the secondary color of the current winning player. So if the red player is in first place, the screen on everybody's game client will be red. If blue is winning, then it'll be blue. If nobody's winning, if it's a tie, then it'll just be its regular old black color. So what we'll do is we will loop through our game state, just like we did before. Remember, the game state is attached to our game object. So we'll say for player in self.game_state. We'll get the player. Player is currently a string, so we'll turn it back into a dictionary using json.loads player. And then we'll check if the player number, if that player's number is equal to our current winning number, self.winning player. And if it is, then let's fill in the surface, our display surface, which is the name of our game window, display surface dot fill the player's secondary color, so S color. Now, you might say, you got a for loop right here and you're looping through, why not just do it right in here? Well, with drawing and blitting to the screen, the game window, I guess you could say it's like sequential. So like we want to draw the background in first and then draw the things that go on top of it next. If we drew these things first and then drew a background, that background would go over everything else and you wouldn't be able to see it. So we got to do this first. All right, perfect. So now, and also I'll just say here, what if the player's winning number, what if winning number is 0, then none of these are going to match? Don't worry, because what are we doing first? Down here in our main game loop, we are filling, as a default, we're filling the surface black. So that is okay. That is okay. All right, so that will draw the background in the way that we want. So now let's work on displaying the score. So kind of like before, I'm going to create a list. I'll say create a list to hold all scores. So we'll say current scores, it will be a blank list, and it'll be a local variable. And I'm doing this because I've got another for loop here, which is running, which is kind of nice. But I don't want to write the scores in here because I could write the scores and then write a player on top of it, and you wouldn't be able to see the scores. I want the scores to be on top of everything else, so I'm going to draw them. I'll draw them last. However, inside of this for loop, there's no reason why I can't get access to all of these players' current scores. So let's do that. So we loop through our game state for each player, we turn them into a dictionary, and then right here I'm going to say prepare the score to be drawn later. All right, so I'm going to first just create a score variable, and I'll put some text in here. It'll be a P for player plus, I want a string representation of the player's number, so the current player's number. So it'll be like P1, P2, P3, and then I'll put a colon with a space, and then I will add to it the string representation of this player's score. So it'll be like, P1 colon 5 if their score is 5. So that's the message that we're going to use. So now let's create a score text object. So score text, let's render it to the screen. So we'll call the font object that we had created way back in like video 1, font dot render, and then we'll put the message that we want to render. It's our score message. Anti-aliasing is always true for us, and the color I want is white. Now I'll get a rect for this score text. So I'll say score rect is equal to score text.get rect. And now what I'll do is I will position the score rect based off of the player number. So like if my game window, player 1, I'll have the score be where they started, player 2, I'll have the score be where they started, or similar, close to it, player 3 where they started, and player 4 sort of where they started as well. So we'll come over here and we'll say if player number is equal to 1, then we're going to use, we want to position this in the top left corner. So I'm going to use the score rect's top left attribute to do this. So I'll say score rect, move my cursor, score rect dot top left is equal to, remember, the rects need a coordinate where it's the starting x value, the starting y value, and oh, no, to position, I'm sorry. To position, we just need x and y values. So our x value, I'm going to use the player's starting x value, and then for the y value, I will use the player's starting y value. So the particular player in this iteration of the game loop, if its player number is 1, we're going to find their starting x and starting y, which is right up here in the left-hand corner, and we'll put the score right there using the top left attribute. I'm actually going to copy this because we're going to see that we do that quite a bit. Elif player number is equal to 2. We're going to do the same thing, except now top left is, we're going to be over here in this corner. Top left is going to push us off. We're on the right side. So I'm going to use the top right attribute to position. So we'll change that to top right. All right, let's paste another. Oh, we'll do elif player number is equal to 3. Our third player is in the bottom left corner. So top left is going to be bad because it'll push our text below the screen. So we'll do bottom left as the attribute of the rect that we were positioning. And then I'll just do an else block here to catch the fourth player. I think that should be fine. The fourth player is in the bottom right corner of the screen over here. So we'll say, we'll use the bottom right attribute to position the rect. Awesome. Lastly, what we'll do right now is we've got this list of current scores. We said we're not going to draw the score right now. We're going to draw them later, so we ensure that they are the last thing that is drawn. But I should append the current score to our list. So I'll say current scores dot append, and we'll append it as a tuple. We'll do the score text, so score text, and we'll do the score rect, because we know that when we blit, if we just scroll down, right, when we blit the text to the screen, we need the time text and the time rect. All right, so we'll do that right there. Awesome. So this looks pretty good. And then if we continue on in this for loop, we're drawing the given player. Once we've drawn the given player, we're drawing our particular player with an outline. And so then this is the last moving thing that we're drawing. Like, I don't really care about the time and the player. Those are static. They're not moving. So once I've drawn our player, now I will draw all scores last, so they are always on top, we'll say. So we'll loop through our list of current scores. We'll say for score in current scores, we'll blit them to our display surface. So display surface dot blit. What do we want to blit? Well, if you look, we appended it as a tuple. The text is the first element, so we'll do score at index 0, and then the rect is the next element, so score at index 1. All right, so I think we're pretty good here. You know what? One last thing. Since we're in the draw method right here, I think what I'm going to do is we're drawing an outline, a magenta outline around our player object. But the server is going to change the size of the player. Whoever's running the server can make them really small, so it's hard to collide, or make them really big, so it's easier to collide and it's more chaotic. I want the size of the outline here that we're drawing to sort of vary with the player size. So instead of hard coding it as 2, what I'll do is I'll do self.player.size. All right, so we're getting our player object size, and I'm going to divide it by 10. So if the player size is 20, we're going to outline it by 10. If the player size is 40, we'll outline it by 4, and it'll grow with the player. This, I believe, is going to give us a float because we're doing division, so I'm just going to cast it to an integer so that we have the thickness set the way that we need it. All right, I think this is perfect. Let's actually test this now, and if this works, I'm going to be super, super happy. So we're going to run our server, and hopefully now if we run our game with our clients are going to send their updated gameplay state to the server. The server is going to compile it for all players, and then they're going to send an updated game state back to each client, and we're going to use that updated gameplay or game state to kind of like draw these changes to our respective boards. So I'll hit enter to start. Oh, and we've got an error. Of course we do. So let's debug this in real time. Where is it? Okay, so it looks like it is in my server file on line 252. I've got a spelling mistake. So line 252 on my server. 252. Look at that. So I said player info JSON is player socket.rect. It's not .rect. We want to receive RECV. All right, RECV. So I got to make sure you change that. Hopefully you didn't make that mistake, and maybe you laughed at me when I made it. Like, what's this guy doing? He doesn't know what he's talking about. So now we'll change that. The server is running. Okay, let's check our clients. Hopefully this works. Second try is the charm. That's going to be our phrase. We're going to be optimistic here. So here's this player. Here's this player. I press enter to play. Enter to play. Oh no! And look at that. We got another error. So let's just see. We'll debug it in real time. String object has no attribute encoder. Oh yeah. So if we go to line 307 now in our server file, 307 in our server file, right here. Player socket.send. I have header.encoder. That's not right. It's encode. We call the encode method. So that was in my send game state method of the game class. So right here I had to change encoder to encode. All right, so I really wanted it to be second try is the charm, but I'm very confident now that third time is the charm. Third time is the charm. So I'm going to run this. We'll set this up. Again, live debugging, it's good to see it in real time. These are pretty easy errors though to fix. I mean, these are just kind of oversights on my part. So we're going to move this here. I'm going to move this over here. We'll press enter. On our client side, I'm going to scroll down to our games update method. So I'm going to scroll down to our games update method. If you look here, we have if self.roundtime is equal to 0, we should have stopped the game, and we didn't do it in our last video. The time just kept going to negative. So the reason why I think that was happening is self.roundtime, I believe, is a string at this point because we received it from a JSON object. So what I'm going to do here is I'm going to simply cast this as an integer. So we're going to cast that time as an integer, so now we can do a proper comparison. And let's test this. I'm going to go over to my server, and let's just change our settings. Round time will be 2 seconds, and players will be just 1. So we can just test it. And we'll see if our flags change and if our status message changes as well. So let's test this out. Hopefully that will fix that issue. All right, so here is our game window. I press enter. I can move. and I can't move anymore, and it says game over. Press enter to play again. So that has helped out a ton. Perfect. So now if we notice here, our status message says press enter to play again. So we are prompting the user to hit enter. That is a Pygame event, and we know that we check for events in our main game loop. So if I scroll down to my main game loop, let's see where we're processing our Pygame events. Right here is our main game loop. Here we're emptying the event queue, and we're checking to see if the user has pressed a key and if that key is enter. Well, this is really similar to what we did when we wanted to ready the game. In fact, right now, a lot of the things are the same. If you think our player is waiting right now, we had set the is waiting flag to true, and we have our total number of players in the game. So how are we going to distinguish this state where we're resetting the game versus where we are readying the game upon like the game first starting up? Well, if you recall, we have a Boolean flag for our game called isActive. IsActive is false right here when you first start up because the game isn't actually running. So we'll use that flag to trigger a reset. So we'll check if my player.isWaiting and my game. Remember, we're outside of our game class now, so we'll call things my game and my player. They're outside here. We'll say my game.isActive. So that means the game has started. It is active, but now the player is waiting, which means a round has ended. We're going to call the game objects my game.reset_game. We'll call the game's reset. So let's actually go write this reset method right now. So I'll scroll up to the game objects. All right, we're in the game object. 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 Here it is. Here is the game object's reset game method. So let's just quickly talk a little bit about what we need to do in our reset game method. Well, first, let's reset our clock. So we know the clock got down to 0. We'll reset it to our round time constant variable, the starting time that we got from our server when Pygame initialized. So we'll do self.roundTime is equal to round time. Next, we were keeping track of the winning player and the high score. Well, we're going to have a new round, so let's reset those to 0. So we'll do self.winning player is equal to 0 and self.high score, oops, no capital S, high score is equal to 0. Awesome. Next, let's reset the player. Okay, so we're saying, hey, it's time to reset the game. Well, we've got a player that is in the game that probably needs to be reset. So we'll say reset the player. And why don't I I'll put some little stats here. I'll say reset the game and reset the player. So the player has its own reset method. We'll call it here. So we'll say self.player. We're inside of our game object. So to get the player, we do self.player, and we're going to call its reset player method. So let's go write the reset player method of the player class on the client side right now. So here's our player class. If I scroll down, you can see our reset method right here. So what exactly do we need to reset on the client side? Well, we're going to want to put the player back in its starting position. So we'll say self.x is equal to self.startingx. So we'll grab its starting x value, and we'll do the same thing for self.y is self.starting_y. And then we'll update our coordinate. So we'll say self.coord is equal to, as a tuple, our x position, our y position, and remember, this is going to help us draw our rectangles, draw our recs to the screen. So this is where we're starting, x, y, and then how wide? Self.size. How tall? Self.size. Wonderful. Another thing that we should update when we reset the player is update our Boolean flags. So if we are resetting the player, it means the user has hit enter to play again. So we are no longer waiting. So self.isWaiting is going to equal false. We're not waiting anymore. We are ready to play. We're just waiting for everybody else to get ready. So we'll say self.isReady equals true, but we're not playing yet. So we'll make sure self.isPlaying is false. And then let's update our status message. So self.status message is equal to ready ... waiting for other players. All right, great. So that's all set. So now let's head back to the reset method of our game. So let's go back to our game's reset method now that the player's reset method is complete. All right, so here is our game's reset method. And so we've reset the player. So what we now need to do is send the updated player status over to the server. And we have a method. We have our send player info method that's already written that will do this. I'm just going to pause the video. I just got to cough for 1 second. Oh, that was much better. I didn't want to cough directly into my microphone. So after we've reset the player, we're going to send the new player's information over to the server. So we'll say send updated status to the server. And so we'll say self.send player info. And our send player info method will build a dictionary with the new coordinates and the new flags, and it will ship it off to our server. Perfect. Now, one of the things we'll just say here, and the last thing that we'll do in our reset game method, the server will now know that our player is ready. But if you recall, the server will wait to get confirmation that all players are ready. And once it has it, it will send information back over to the client where their is playing flag is then set to true. So we need to monitor for that incoming message. And so we're going to do it in a thread. So we'll say monitor for the start of the game from the server. Okay, so we'll call this start thread, and we'll say threading.thread. And what do we want to target here? Well, I think we got a start game function. Yeah, we got a start game method right here. Let's target our start game method, which is going to receive that player info message. And if the player's is playing flag is true, it's going to trigger the game to start back up. So that should work nicely. We'll say start. Oh, I can't forget that self keyword. So self.start game. I made that mistake before too. I'm making a lot of mistakes, similar mistakes. And so now that we've got this thread, let's start the thread. So we'll say start thread.start. Start thread.start. Okay, perfect. So now when we want to restart, as soon as everyone agrees, we change our player flags back to be playing. And so right now, if we try this at the end of the game, is my server still set to be just 1 second? Yeah, okay, cool. I'll put 2 players in so we can actually see it a little bit better maybe. If we run the server, all right, let's run some clients. Client 1. All right, perfect. We'll run client 2. All right, perfect. Client 1, client 2, press enter to play, press enter to play. Whoa, so much fun. The game's going to end. Okay, so now the game is over, and so we're prompted to press enter. And so when I press enter, let's see what happens. It says ready, waiting for other players, ready for waiting for other players, and that looked pretty darn good. Game over, game over. All right, hey, all right, enter, enter. Oh, we still have a red background. That's not good. So we have to do some resetting. If you notice, scores are not resetting. So there's a little bit I think we still need to do on the server side when it comes to resetting our game. So let's head over to our server side right now, and let's take a look at what we need to do. Okay, so on the server side, I think we've got a reset player method and a reset game method that we're going to look at both of these. So let's start with the players method. It's super easy. So the reset player method, all we need to reset is the player's score, right? We saw that when the game ended and we had points, those points were still on the game board. We don't want that to happen. We want the scores to go back to 0. So inside reset player, we'll just simply say self.score is equal to 0. And that's on the server end. That's easy. Perfect. So now let's scroll down to our game objects reset method. So reset game. Here we go. Reset game. I think we got to do a little bit more to reset the game here. So inside of reset the game, the first thing we'll say is we'll reset the game. And so what information over here on the server side do we have to reset? Well, we've got a round time, and if you recall, I'm just going to put this here so we know where we are at. If I just scroll down a little bit, I think it's in process game state. Our round time, we keep decrementing it, so it gets lower and lower and lower. When we reset the game, let's set it back to whatever the round time of the game is set by the server. So self.round time is equal to round time. And then let's also set the high score in the winning player back to 0. So we'll say self.high score equals 0 and self.winning player equals 0. I paused the video because I was like, this doesn't make sense. High score and winning player are not over here on our server. We never defined them. Those are defined in our client's game. I'm so sorry. I was getting confused here. If we go over to the client game, you see we have high score and winning player over here. We don't need to define these as 0. We can get these out of here. All we really need to do to reset the game is simply set our round time back to whatever that constant value is, like 30 seconds, 40 seconds, 50 seconds. And what we'll do is I'll also, in here, I'll reset the player by saying self dot, oh, I've got the player right here. So we'll do player dot reset player. Now, the question is, with the reset player and the reset game methods complete, where do we want to call them? So we just want to call them on the server side when we want to reset the game on the server. And so we're going to do that in our ready game method. So I'm just going to scroll up. Here's ready game right here. And so we won't reset the game as soon as the game is over, because when the game ends, I want the message to say, you know, game over, press enter to play again. I want the player to be able to see the results of the game. So I want them to see the scores and who won as they're deciding if they want to play again. However, once they hit enter to play again and pass that information over to the server, and that information is received right here, then and only then will we reset our game on the server side, essentially wiping the score and repositioning our players. So it's going to be right here that I'll say reset the game. So we'll call self.reset game, and that will reset our game and it will reset our player. If you notice though, reset game, it needs a player to be passed in, so we'll just pass in the player that is attached to the thread that this is running on. So we'll pass in player right here. Okay, so if we test it out now, I think everything should work. So let's actually change, I'm going to change some of my settings here. And let's see. I'm going to change it for 4 clients. So we'll do 4 players. We'll give it a full test. And I'm just going to change the room size so everything fits a little bit nicer here. We'll do 40. Round time will be, we'll do 25 seconds. All right, so I'm going to run the server. All right. And now let's get 4 clients to connect, and let's see if every feature of our game is working. All right, so here is my first window. Looks good. We'll run my second window. They keep opening up on my second monitor. I don't know why. Here's my third client connecting. All right, that looks great. And here is my fourth client connecting. All right, so now we got all 4 colors. Let's just see. I'll press enter on each one. So what I'm going to do is I'm going to run the server here on my static IP address of 192.168.1.7, and we've set this up previously to be a static IP on our router, and we've enabled port forwarding here so that any external traffic that comes into my router at port 12345 will get routed to my computer. So hopefully some family that I have in a different house are going to be able to connect and play against us here. So let's check this out. I'll run the server. We'll get the server going. So the server is listening for a connection. So I'm going to run a client here on my end directly. So I will be playing as the red player here. Perfect. And so if we just come over here, we see that we have that connection right there. We'll bring in another machine here. Perfect. On my same LAN network. So, but different IP address, different computer this time, 192.168.1.78, the green player. And I'm going to pause the video and just reach out to some people in a different location and see if they'll join. And so as soon as they join, I'll unpause. Okay, so it looks like we've got 4 players in the game here. You can see we're no longer accepting new players, and you can see we have 2 players that are from a different network. So instead of coming on that 192.168 address, like these 2 machines that are on my local area network, we've got 2 coming in from 67 dot something dot something something something, and I'm not going to reveal their public IP. So I think everybody has hit enter at this point except for me. So as soon as I hit enter, hopefully we'll see the gameplay begin and some chaos ensue. So here we go. I'll hit enter and we'll see. So here we go. We're playing now. All right, we got people moving. Green takes the lead. It's a tie game again. Oh, here comes red. Got to move out of the way. I want to get. Oh, there we go. It's a tie game between green and red. Green's taking the lead. I can't lose the game. I can't lose my own game. That would be bad.